Hey, what's up, guys? This is Chung here, and so this time, let's take a look at this uh, problem number 698. Partition to k equal sum subsets. Yeah, this is a very classic problem for the recursion plus the backtracking. You know, uh, very classic one. I'm gonna give it my own like here. So basically, you're given an array here and the k here. Basically, that's the group number here. You are supposed to you need to check with the given group number here. Can you divide this array into this group numbers where each group have the same sum, right? For example, this array here, the group is 4. So this one can be divided into 4 groups. See, 5, 1, 4, 2, 3, and 2, 3, where each group has the same sum, which is 5, right? So that's why we return true here. If we can't, we just return false. So how should we tackle this problem, right? I mean, if you watch closely, so I believe it's not that hard to come up with one fact, which is we can simply use the sum of this arrays here, right, and divide it by the group by the k, which is a group here, and then we can get the target sum, right? The target sum for each group. In this case, the total of sum is 20, right? And we just divide it by 4, which is 5, right? And with this 5 here, right, we can just use the recursion plus the backtracking to try to add. Basically, we'll keep a running sum here, right? Uh, we're gonna have like a backtracking method here. So backtrack, or you can call it DFS, whatever you want. So we're gonna have a current sum here, right? And of course, and also the k here. With the current sum, every time, right, we check if the current sum uh, is equal to the target, right? To the target, which is 5 here. If it's equal to the target, we know what? We know, okay, we find a group, right? Then let's try another group. So then we'll do we'll call another backtrack here. Basically, we'll return here, right? We'll return another backtrack here. Backtrack with the current sum equal to 0, right? 0, and the group here gonna be k minus 1, right? Because we basically will keep doing it if, right, until we see until we have allocated all the groups here. So basically, if there's we're gonna have another check here. Basically, if k equals to 0, then we simply return true, right? We just return true. So that's that, right? Every time okay, so first we check this. That's basically that's our ending condition here. Or if it's the same, if k is not equals to 1, I'm sorry, if the k is not equal to 0, but the current sum equals to the target, we just do a recursive call, right? Basically, we call this one. And if the current sum doesn't equal to target, right, what do? We do a we do a for loop, right? Basically, we do a for loop. We loop through all the all the numbers that we haven't seen before, right? And we'll use the current sum, right? We'll use the current sum plus plus each number. Because we need to loop through each one of them, right? That number, right? And we're only going to and then we're gonna do another like DFS call. So basically, we're going to call the same thing here, backtrack, backtrack, right? With this new number, right? With the new number here, but in this case, the k is still one. Sorry, it's still k because we haven't find a group yet. So we just keep doing it until we find it. But meanwhile, when we do this, we have every time we find a number here, we need to add that to a. We're gonna have a visited, right? Or seen visited visited array here. We're gonna set this one to true, and once this is finished, not finished, right? So if this is not true, right? And then which in the for loop here was in the end, if it's this one is not true, so basically which means we cannot find a valid array, no, a valid group by looking at this number. So in the end here, we're gonna set this visit to false, right? That's how we do a backtracking here. And yeah, okay, so that's the basic algorithm here. I know it's a bit confusing here, but I'll try to explain a bit more while I'm coding here. Okay, so let's do a quick check here, right? So like I said, we have a target. Let's do a remain here. Remain. We do div mod, right? With the what sum, right? Of the numbers, right? And then we do divided by k, right? Then we'll have this target and remain. We can do a simple check here, right? So if there's any remaining, then we simply return false, right? It means that there's no way we can evenly divide this the sum of the arrays into these k groups, right? So that's that. And then okay, let's do a define like a backtrack method here, right? Backtracking backtracking method here. So like I said, we're gonna have a sum, right? Running sum and a k here, right? And let's only keep these two parameters for now. We can add some improvements later on. So and here, like I said, we're gonna have a visited, right? I think at this moment I will just do a visited false, right? For all the numbers here. We're gonna have n dot length nems, right? So start right. And in the end, we simply return the backtrack, right? Backtrack, uh, current sum is, we start with 0 and k, right, here. And in the backtrack method, first we check, right, if k equals to 0, right, which means we have already allocated all the numbers, right, basically to k groups, then we just simply return true. We know we already find the final result, right? And then the second one will be if the current sum, right, is greater than k, I'm sorry. Actually, yeah, we can do that. So we can do a current sum is greater than target, right? If it's greater than target, we can just do a return false here, right? I think this will help improve the speed a little bit, but I'm not sure how much will that be. So, but anyway, it doesn't hurt. We have this check here, right? Basically, as long as the current sum is greater than target, and since this is a positive number, right? Since this is a positive number, sorry. Oh, okay, sorry. So given a number, it doesn't, does it say, okay, yes, okay, it says that. All right. So in this case, all the numbers in the array is a positive number here, right? So we can have this check here, right? So because we know as long as it's already greater than target, there's no way it can be smaller, can go back to target. We can have an early termination here. Otherwise, if there could be negative numbers, we cannot stop here. We can just we should like remove this one. But in this case, it's safe. We can add this one. But you know what? Actually, to make this like solution more generic, I'll just remove this for now, right? And let's do sorry, where was I? Yeah. So if the current sum is equal to target, right? So what does it mean? It means that the current sum, right? The current sum is a target, which means we find another group, right, with the sum equals to target. Then we can just do we just simply return the backtrack here, right? We can just continue calling this recursive backtrack method with the current sum 0, right? Because basically it's a new start, which means we need to find other numbers which can construct another group with the target with the sum equals to target, right? And in this case, because we already find one, so we have to decrease the k by one, which means all right, we find one. Now let's do a k minus one. Let's see if we can find uh, the remaining numbers with k minus one. So how are we uh, marking which what are the numbers we have visited, right? So the sequence of the check here is important. So basically every time we check this one, if it's an equal, we don't go this for loop anymore, right? Basically, and here we just do a I equals to a in range, right? Right. So that's the naive iteration basically, right? Basically for every time if the backtracking is not the sorry, if the sum is does not equal to the target, we just loop through from the numbers, right? And if let's do a yeah, and then let's do a number right equals to a nums I, right? So first we'll see if the I is not sorry, if the visited I has not been visited, right? That's the first and, right? And what? And the current sum, right? And the current sum plus this number, right? It's not greater than the target, right? Then then we'll be basically will continue. Otherwise, if this one, if this number plus the current sum is greater than target, then we know there's no way we can form another like group with this combination, right? So if it's valid here, then we know okay, now we can mark this like then we can mark this visited, right, to true because we and then we'll do like another backtrack, right? Backtrack with current sum, right? Plus num, right? And then the group is still k. And then in the end we just need to mark this thing back to false, right? So the reason we need to mark this true here is because inside here, right? We don't want because we're assuming we already picking this number here. So we don't want to double process this number, right? We are making sure we only pick this number once, right? And then here, once this is finished, right? Actually, uh, simply doing the backtrack will not help us. Uh, not helping us, will not help us, but there's some issues here. Basically, and so this backtrack here, right? So if this backtrack, this backtrack will return a value here, right? It's going to return like a false, I think. So if this backtrack returns true, right? If the returning true, we don't want to mark this visited back to false. Why? Because if it's returning true, we know, oh, this number is the number we want, right? We want to keep this visited I mark equals to false, so that when we process the others, we will still have this visited equals to false. We only mark it back, sorry, so we still have this visited for this number marked to true, and we only mark this number back to false if this backtrack return false, right? Because then we know, okay, this try is not gonna work, right? So we'll revert this number to be non-selected because we know that that wasn't a valid choice option, right? So what we do? So if backtrack returns a true here, right? What do? We just simply return true here. We return, right? But if it's false, we don't return here. If it's false, we want to continue this for loop. We want to try another number, right? And then to do that, we will need to mark the previous one to false because that's it means okay, we tried this number, it didn't work, so let's try another one. But before trying another one, let's set this like this number to be unvisited, right? Okay, and so as you can see here, right? So let's say let's go through this algorithm here from 0, right? And it comes to here, it's not the current, and then we go here, we go here, and then we mark the first number to be visited, and then we recursively call this one, right? Recursively call that. And once this, and remember this one was marked to true, right? And let's say the next iteration, let's say, oh, we find like a current sum, right? So it is it's equal to the target. Then we see we directly go into another backtrack call, recursive call here, right? Without going through this for loop here. So which means what? So the numbers had already been visited, which is marked to true, will stay with true, right? Only only when this is only when this thing will return false somewhere here, then it will reset all the previously visited back to false, right? Otherwise, if the path continue return true, right? All the visited here, all the visited nodes will basically will keep as true until we visited all the nodes, right? So that's why I said the sequence is very important. Basically here, um, if we see a target, we keep calling the backtracking. And every time when we find a current number and we satisfy this condition here, we set this one to true. And here, this is another important case here. We only return when this one is true, basically. If this is false, what do? We know, okay, it's not gonna work, so we need to set this one to false, and then continue the for loop, right? Because other number may give us a true return here, and if none of them will give us like a number a valid number, in the end we return false, right? Okay, so another thing is that another improvement we can have here, as you probably already noticed that every time here we do a for loop, we loop through the entire numbers again, right? What we can do here, we can have a like set another parameters as the index here, and here, right? Instead of starting from 0, we can always start from index, right? From index to number, so that so once we have this I here, right? We know we already processed I here, so the next we only want to process the second one, the next one after I. Sorry, I is not index. So we don't have to process the ones we already processed, right? So if the current index, let's say, is 2, right? So and then we know, okay, we want to start from 2 here. So let's say the first one is 2, right? The first one is 2. Let's say, okay, so the first one, we add this one 2 to the index 2 to be visited, and then we'll we'll pass this one alongside to the rest of the backtrack, which means we already processed 2. Now it's time to process 3, I plus 1, right? That can also improve our algorithms a lot. Yeah. So in the end, it's just this thing here. I think that should. Oh yeah, here. Okay. Since we introduced a third parameter, we also have like using a 0 here. And same thing here. Okay, so here will also be 0. Why? Because we already processed the sum, current sum here, right? So it's this one is like as if it's starting from a new a new iteration, just like what we started. Instead, only difference that now we're only looking for a k minus 1 group, because at this moment, even though we're starting from 0, right? Because the first one may not be picked, right? So maybe if there's an array here, right? So there's some like 1, 2, something, right? Because at this moment, maybe only maybe some of the array right in the middle got picked first, right? And then the first one still haven't picked yet. So if so, every time we see a current sum equals target, not only we need to set this current sum to 0, we also need to set start index from to 0, because we know we will need to start from beginning again. And at this moment, right, since we already uh, gone through this for loop, right, we must have gone through this for loop. So whatever this current sum, right, uh, whatever number that was inside this current sum were already marked to be visited here, right? So that we know when we go in here, when we do when we start from the start looping the node, the numbers again from the beginning, whatever have been already visited here, right? See, we have a check here, right? We have a check here. If it's not visited, then those numbers that have already been visited by doing this sum here, constructing this current sum here, will remain visited, so that make sure we're not reprocessing those node has been visited before, right? So I think that's should do it. Let's see. Yeah, cool. This one works. It's not that straightforward to understand. It took me a while to fully understand this solution here. And you know, once you know the solutions and you're looking at this solutions here, and you'll be like, yeah, it kind of makes it. Of course, it makes sense. It has to be done like this. You need to do this, and you need to do a for loop, and then you need to mark it, and then you need to return it here when it's true, because we don't want to lose the flag with this like already visited, if it's a valid one. Then in the end, you just return true if this is true. But if you don't have the whole picture here, at least for me, I find it's pretty hard to come up with this solution by myself. Yeah. Or maybe it's just I haven't done enough practice. So, but anyway, I think to me this is like like kind of like a template. You may want to write it down and review it once in a while, so you have a so you can basically you can really master this kind of like classic problem or template. All right, cool guys. I think that's it for this problem. Thank you so much for watching the video, and I'll be seeing you guys maybe tomorrow. Yeah, thank you. Bye.